In this video, we'll run through some of the more challenging questions from the 2019 VCAA exams. So in this first question here, this is the second part of a two-part question from exam 1, looking at question 10. So initially we were told there's a least squares line used to model the relationship between monthly average temperature and the latitude recorded at 7 different weather stations. And we're given the equation. Now in this case, the equation needs to be used for us to work out the correct answer for question 10 here. So we're told the coefficient of determination is calculated to be 0.893743. So remember, coefficient of determination, that is our R squared value. And so we want to find the correlation coefficient to 3 decimal places. So they want us to find R. So we are going to need to find the square root of that R squared value that we've been given. And the second thing we're going to need to take into account is the direction or the slope of the graph. And so here we can see we've got a negative gradient. So that means we've got a negative slope. Our data will be travelling down the page. So that is important because our R value means that will also be negative. So looking at the options, we can see it can't be C, D or E. When we take the square root of the R squared value we've been given on our calculator, we get a negative, or we get 0.945, which we can then determine is negative. So that's why this was such a challenging question. A lot of people got 0.945, but then weren't sure whether it should be positive or negative. And the second issue was the recognition that we're dealing with coefficient of determination, R squared, and asked to find correlation coefficient, which is our R value, or our Pearson's R. Okay, the next question, question 11, we only had 37% get the correct answer here. So a study was conducted to investigate the effects of drinking coffee on sleep. In this study, the amount of sleep in hours and the amount of coffee drunk in cups on a given day were recorded for a group of adults, and they're summarised in the table below. On average, for each additional cup of coffee drunk, the amount of sleep is, and we've got options here of increasing and decreasing. Okay, so what we want to first work out is what they're asking us for. So you should be able to recognise this sentence here. On average, we're talking about a change in the coffee based on the change in sleep. So that's referring to slope, okay, or our gradient value. The second thing is when you're given a table with mean and standard deviation and an R value, that means you want to turn to that section in your bound reference where you're calculating the least squares regression line using a couple of little equations. And our equation for slope is the standard deviation of Y times our R value over the standard deviation of X. And so in order to answer this question, we've got all the pieces we need. It's just a matter of putting them together. So here we need to work out, well, what is Y and what is X? So what is the explanatory variable? We are saying that the amount of coffee is explanatory because it is giving us a response in the hours of sleep. Okay, so that means our SY is sleep and X is coffee. Okay, so putting that into our slope, we've got standard deviation of Y, so 1.12 times the R value, negative 0.770, divided by standard deviation of X, so 1.56. And so when we pop that in our calculator, that's where we get our rounded off value of 0.55. It's negative 0.55, so that means we've got that decreasing value. Okay. The next question we're looking at, question 13, is more of a time factor. And so if we look at this, we've been given some time series data, and then we're told both the 3 median smoothing and the 5 median smoothing are being considered. For both of these methods result in the same smoothed value on which day. And so it comes down to a case of, do you have time to work this out? Okay, and so if you do have time, what you can do is actually just do a 5 median smooth, do a 3 median smooth and see where you get that same result. Okay, you can either do it graphically straight onto the graph here or using the table of values. But remember, with your median, you need to order the values and find the middle one. So if we do the 3 median, I'm going to do it on the graph. Remember, I'm just looking at the first group of 3 points. The middle working across will be in line with day 2. The middle working up from the bottom will be this value here at about 28. Okay, so we can put our dot there for our first point. And we just continue to move our way across, moving across one day each time, and then each group of 3, because there's 3 points, the middle will be the second point in line. And if you're always working away from top to bottom or bottom to top, just be consistent. You'll be able to pretty quickly and easily mark out those points. So there's my 3 median smoothing. Don't really need to join them, but I will just for the sake of showing you there. Now I'll just pick up a different color and let's do the 5 median. So same idea, 5 points. Okay, 1, 2, 3, 4, 5. The middle working across will be at day 3. The middle working up will be in line with the third point from the bottom. And then we move our way across. Okay, so again, 2, 3 points will be in line there. Moving across 1, so 1, 2, 3, 4, 5, and working up from the bottom, 1, 2, 3. So it is time consuming. Working our way up again, 1, 2, 3. And so once we've got all of those in, we can see it's not until day 7 that we have that value is the same as when it's a 3 median compared to a 5 median. So as I said, it is a time factor with this one. It's towards the end of the module because remember our data and stats questions always go in order of the course rather than order of difficulty. Okay, so looking at question 15 now, another median question. We've got a time series plot showing 12 months worth of monthly rainfall, and they're asking us for what is the median monthly rainfall for 2017. Okay, so remember with our median, we're going to take all 12 values and we want to find the middle value. So you could put that into your calculator and work it out just using your best estimate for the points that are on the graph there. Or we can simply just say, well, there's 12 points. The median is going to be in between the number 6 and number 7 point. And so if we know that if we start from the bottom and work our way up, we're working from the smallest value up to the largest value, or vice versa from the top down. But we want to find that 0.6, 0.7 and work out where the middle of those two values are. Okay, so working our way up, we've got June is at the bottom, and then so that's 1, probably Jan, March and April are very close, so that's 4, November, and then I would say that July is the 6th value. The next biggest working up is September. So we're looking at the values between, so it's at about 110 and about 100. And remember, find the average of those two, so 105. Now we've estimated that, but that's enough information for us to see from our options that D has to be our answer. We could have also knocked out a couple of the options there, so definitely the bottom values, so 53 and 82, and then it would be a case of just trying to do your best effort to work out what's left if you weren't sure of what to do. Remember, you can estimate each one, put it into your calculator too, and that will work just fine. It'll just take a bit longer. Okay, so now we're moving on to some questions from exam 2. These were all questions that less than half the state achieve full marks on. So some of them are not as difficult as others, but just running you through some of the common issues or challenges that students had last year. So in this question, we've got a 5-number summary for a distribution looking at minimum daily temperature for the months February, May and July in 2017. And so we can see there's their table of the 5-number summary, and then we've got the associated box plots here. So the question is asking you to explain why the information supports the contention that the minimum daily temperature is associated with month, and you need to refer to an appropriate statistic in your response. This is worth 2 marks, this question. So they're already telling you there is an association. They are looking for you to identify why. So what is it from the box plots that is telling you there is a relationship? And second mark is for giving an appropriate statistic. So when we want to, when we're identifying a relationship, we're saying that there is a change. So as the time is increasing here, we're seeing a change in our data. And so if we look at the key statistic, our median, so we can see our median, and we can see it from the table as well. Our median value has dropped from 10.9 down to 7.5 down to 5. So there has been a consistent change over time. And so what we would be looking for you to identify is that the median is decreasing. So the median daily temperature is decreasing as the months change throughout 2017. And then we would want you to back that up by saying, as can be seen by a median of 10.9 in February, reducing to 7.5 in May, and finally to 5 in July. And so there's an example of an answer that you may give, making sure that you've done 2 very clear things. Okay, so the next question we're looking at, question 5. We start by being given a scatter plot, okay, with a least squares regression line drawn on it. And so what we're measuring here is the atmospheric pressure at 9 a.m. Against the atmospheric pressure at 3 p.m. I think one of the most challenging things with this question was the wording of the variables. The actual mathematics sitting behind it was, as we always expect, and straightforward. But what we're seeing here is the complicated variable names is making it difficult to structure sentences well and be able to give the answers that you need to do. The other thing as well is when we're looking at the question here, so they've given us the least squares regression line and they're asking us to interpret the slope. Okay, so quite often we find answering questions where it asks us to interpret challenging. Interpret means you have to give meaning to. It's not simply just stating the value. So here, if we're interpreting the slope, and our slope from our equation we can see is 0.8894. We're wanting to write a sentence that relates the 2 variables and that slope. So remember, we're saying that for every increase in 1 hectopascal of pressure at 9 a.m., we are seeing a 0.8894 hectopascal increase at 3 p.m. So being very clear that we're saying those values in the variables in the right order and picking up the correct value for the gradient. So you should have an example or a sentence like this, very much like this in your bound reference, but it's key to be able to pick up, well, from that template or those examples that I have, what are the things that stay the same and what do I need to change? And so we're always making sure we're adding in our variable. Okay, so what's our explanatory variable? Where if it's a positive gradient, we're always saying we've got increase here and 1 unit of our explanatory variable. And then we're saying the response variable, if it's a positive gradient, increasing. If it's a negative gradient, we say decreasing or decreases by, and then the value of that slope of the gradient and the units. Okay, so it's worth having a couple of examples so that you know when you hit a question like this, you feel confident of putting in the correct answer. Okay, so continuing on with question 5, but now we're going to jump to part D. We're looking here, so we've now got our scatter plot again with the line drawn on. We've got the equation that's been given to us, and we're asked to determine when the atmospheric pressure at 9 a.m. is 1013 hectopascals to find the residual value there. So First thing, when we're looking at our residual values, we need two components. So remember, our residual is always found by finding the actual y value minus our predicted value. Okay, so to get our actual value, we're going to read that from the scatter plot, from the graph they've given us. To get our predicted value, we're going to use the equation, the least squares regression equation. So first thing, let's identify our actual value. So when the 9 a.m. value is 1013, so that is here, we've got one data point there, and that reads straight across to 1015. Okay, so that's our actual value. And so now if we calculate our predicted value, so using the equation, so our predicted will be 111.4 plus 0.8894 times this x value, so 1013. That gives us a predicted value of 1012.3622. Leave it unrounded until you get to the end. I know it's asking for a whole number as our answer. And so here, we're just going to put that value in here. So 1015 minus 1012.3622 gives us a residual value of 2.6378. So to the nearest whole number, our residual value is 3. Okay, so still continuing with question 5, looking now at part E. The mean and standard deviation of the pressure at 9 a.m. and the pressure at 3 p.m. for the 23 days is shown below. So we've got a question where we're given mean and standard deviation for our x and y values. Use the equation of the least squares regression line, which I've just put at the top here, and the information in the table to show the correlation coefficient for this data is equal to 0.966. So they're wanting us to use, again, the little equation. So we're using our slope equation where we've got standard deviation of y times our r value over standard deviation of x. And so here, that is the only equation that has the r value in it. And we have all three other components. So we know the slope of the line is equal to 0.8894. We know the standard deviation of y, so the pressure at 3 p.m. would be our y, and so our standard deviation there, and we know the standard deviation of x. So putting all of that together, that means we can say 0.8894 is equal to standard deviation of y, 4.1884, times r, divided by standard deviation of x, so 4.5477. It's really important here, even though they've told you the r value in the question, you cannot use it in your working, okay? You must set up the equation. How would you solve it if you didn't know what r was? And then it depends on how many marks this is worth as to how much working they're expecting to see. It is good practice, though, to at least write out what working you would do. Okay, so here we would multiply across, so 0.8894 times that denominator and divide by this top value, so 4.1884. And that gives us an R value of 0.9657 if I go to 4 decimal places, and therefore it is equivalent to, R is approximately equal to 0.966. Okay, so even if you weren't exactly confident of the algebra in the centre here, you can definitely all do this setup of the equation at the beginning. Now, they've given you that R value for a reason, because you now need to use it in your working for part 2. So in part 2, what percentage of the variation in pressure 3 p.m. is explained by the variation in pressure at 9 a.m.? Here, you're expected to know this sentence relates to your coefficient of determination, or your R squared value. Okay, so they're expecting you to know that from the sentence, that's your general sentence that you would write if you had to interpret that value. And so now to find R squared, we are literally going to square the R value that they've given us. Use the rounded version. Don't use any other version that you have because they've specifically given you that R value in part 1. Okay, and so there we get a value of 0.933156. They want it as a percentage, so we have to multiply by 100 and give it to 1 decimal place. So 93.3% would be our answer there. Okay, this is the final part of question 5 that we're going to have a look at, part F. So the residual plot for the least squares regression line is shown below. So they've given you the residual plot. And surprisingly, a lot of students had difficulty answering this question. And it's mainly to do with we get confused and students actually gave conflicting answers for part 1 versus part 2. So, part 1, the residual plot can be used to test one of the assumptions about the nature of the association between atmospheric pressure at 3 p.m. and the atmospheric pressure at 9 a.m. What is this assumption? So, the thing that the residual plot is testing is whether or not the data is linear. So, what is the assumption? We are testing for linearity. Okay, we are testing if our data is linear, and I don't think I've spelled that right, but you get the gist. Okay, so do we have linear data? If you wrote one word, that's all they wanted here. The second part, the residual plot does not support the assumption. Explain why. So they're telling you that this residual plot does not show your data is linear. When you're checking a residual plot, remember you're looking for, here is our 0 line, so that's our x-axis. What good linear data looks like is a random scattering of points, roughly even above and below the line. Here we have a pattern, so we've got a bit of a curve, a bit of a U-shape happening. So that tells us my data is not linear, and therefore I would need to do a data transformation if I was working further with this data. Okay, so when we're asked to explain why, it's because the residual plot shows a pattern. You can go on to describe that pattern. Okay, you can say it's curved U-shape if you want. You can draw that on the scatter plot, the residual plot that you have on the page, but what we just want to see is that you are identifying that it has a curve, it shows a pattern, therefore is showing that your data is not linear. Okay, so the final question that we're going to have a look at is question 6 from this exam last year. It's not a difficult question, but it's time consuming. Okay, again, it's at the end of this section of the paper, and it does follow, it is something that we haven't done much of. So we tend to focus on scatter plots and lots of stuff around that, but we don't spend a lot of time on this deseasonalizing. Okay, so in this particular year, last year, they did get you to do a fair bit of work for part A. Okay, so here we're given some data for 2 years per season, so over the quarters of the year, the total rainfall, and they've given you the seasonal index for winter. But what we need to do is find the seasonal indices for summer, autumn, and spring. Okay, so there's a few steps involved when you're calculating seasonal indices. Step number 1 is to find your yearly averages. Okay, so that means I'm actually going to find the average for 2015. I'm going to find all the average there. Okay, so when I add those 4 numbers up, divide by 4, I get my average is 160. When I do the same thing for 2016, add those up, divide by 4, I get my average of 150. The next step is to find the proportions, the quarterly proportions. Okay, So you'll have it written as different things in your bound reference, but we're finding those proportions. Okay, so I'll just put it as a different table up here. But basically what I now need to do is for 2015, I'm going to take each of these values and divide it by the average, 160. So I'm going to do 142 divided by 160, and I get 0.8875. Please at this stage don't round anything. You can jot something down, it's a little bit rounded off, but definitely don't round off to 2 decimal places just yet. Okay, so I'm going to keep doing that. 156 divided by 160 gives me 0.975. 222 divided by 160, 1.3875. And for spring, 120 divided by 160, I get 0.75. Now, you may choose not to do winter at all, but I like to, just to make sure that I should get 1.41, and it's a way of me checking that I'm doing the right thing for not much more work. Okay, so I'm going to do the same thing for 2016. Again, each of the values divided by the yearly average. So 135 on 150 and so on. Okay, so once I have those values, the final step is now to take the average of each season. So for summer, find the average. So 0.8875 plus 0.9 divided by 2, and that gives me my index for summer. So to 2 decimal places, that would be 0.89. Autumn, same thing, add the 2 values for autumn, divide by 2, and I get 1.0, so it would be 0.9975 to 2 decimal places would take it to 1. Winter, I do a check, and yes, I get 1.41375, so that is correct. I know I'm on the right track. And finally, the index for spring, so 0.75 plus 0.64 divided by 2, 0.7, so 695. And that gives me my 2 marks. So there is a fair bit of work there for 2 marks, but and it depends on what they did that year. They may have said 1 error, minus 1 mark, 2 errors, you get nothing. But it's very dependent on the examiners each year. Okay, and the final part of this question, you didn't actually need to do part A to be able to do part B. Okay, we've got the total rainfall in 2017, and they're asking us to use the appropriate seasonal index from the table to de-seasonalise winter 2017. So remember, your de-seasonalised is the actual value over the index. We have the index for winter already. So that means our de-seasonalised rainfall will be the actual rainfall divided by the index, and that gives us 185.82. So to the nearest whole number, 186 millimetres. And that's it for the review of data and stats in this section. Hope this helped.